All right, we're just gonna get about started about right now. Let's see. What's up? Oh, did it say? Okay, I'll fix that later. Yeah, it's supposed to say week 2. My bad. Yes, I will fix that later. Well, I'm assuming you guys are not gonna fill out the absence form, so yeah, I will do that later for people who aren't here. Okay, hello everyone. Welcome to week 2. Today we're going to be going a little bit into more depth about sketches and all that fun stuff. We're going to be teaching you geometric constraints, which is something we didn't, or you may have tapped in a little bit in last week, but it really unlocks a lot of sketches, or a lot of more features of sketches, and it makes your CAD process a lot more smooth when you make complicated parts. So yeah, this is like kind of intermediate stuff. So yeah, constraints. So last week I went into dimensional constraints where we use the dimension tool to make things certain lengths. But there are other constraining tools built into Fusion and many other CAD programs, and those will allow you to use geometric constraints. So we were talking a lot about having our lines not be blue, and we want them all to be black and fully constrained. And today we're going to go more in depth on that to kind of show you how to do that without just dimensioning stuff with the dimensioning tool. So up here, I don't know if you've taken geometry. I'm guessing a lot of you have. But there's a lot of geometric constraints up here. This is just an example of some of the ones that you'll use most often. But basically, you can use these in tandem with the dimensional constraints to like make all your lines and arcs black, and then your sketch is happy, and then nothing has to fly around, and then you'll be sad. So up on the top is coincident. So basically, if you want like one point to be like touching a line and they're not, you can use that tool, and then it'll like teleport there, and then unless it's over constrained. But you want to use that if you want like, let's say like a corner of a rectangle to be like on a line, or like a line to be connected to a circle or something like that, right? Collinear is just like if you want two lines to be on top of each other. Concentric, two circles on top of the same center point. Midpoint is pretty useful. So let's say you have like a line and you want another line going through the center of it. That's where midpoint would be useful. I mean, a lot of these have like what it does in the name. The fix tool is something that you won't use a ton, but it is there, and it's just kind of like you have it where you want it and you want to fix it. Generally, it's not recommended you use a fix tool, but sometimes you might have to. And then there's parallel and perpendicular. Those are kind of self-explanatory. But yeah, there's a couple more over here. The tangent one is something that is very useful. So if you have circles that you want to intersect with lines at a certain way, the tangent's really useful. Equals also very useful if you want two lines to be the same, or if you want two circles to be the same. These are all very useful tools, and you will touch into them today. So if you go into the Discord again, we have a worksheet under resources. So if you want to download this assignment 4, and then we can open it up onto Fusion, I think. And then this is basically just a nice quick worksheet to demonstrate all the different constraints. So it's just kind of opens on this plane here, and then you can, under resources, yes. I would open Fusion first, and then, or you can download it and then go to Fusion and then open it from Fusion from your computer, if that helps. And then you say open from my computer on the bottom left. Yeah. And then you can find it right down. Is anyone having trouble opening the document? Okay, cool. So basically, when you get into this document, all the constraints are just placed on this front plane. So if you want to edit this, you can go back and edit this sketch. So in the bottom left over here, you see there's this sketch, the little square. You want to right click it and tell it to edit. And then all of these have like an instruction attached to it, right? So in your sketch, a lot of us we've been using all these tools in the top left, but then there's a bunch of tools in like the center and more the right side, right? And these are all your geometric constraints. There's a bunch of them here, and there's even more down here. So now that we're in the sketch, so you make sure you right click and edit the sketch, you can go in and set these geometric constraints. And for some of these, like your lines will be blue because like these aren't all fully constrained. But the purpose of this assignment is just so you can familiarize yourself with all the different constraining tools, right? So over here on the top left, this one says like make perpendicular, right? So we want to make these like this line intersect at like 90 degrees to this line, right? So up here we can find the tool, right? So this is the perpendicular tool. We can select it and then we just select the two lines. It's very simple, and then it just snaps into place like that, right? So that's how you do it perpendicularly. You see over here it says make all the lines parallel, so you can find the parallel tool, click on that, click on two lines, and then they all like become parallel and happy. So that's just kind of the basics. I'm just gonna let you guys kind of run free for a little bit, just doing the rest of them, and then me and Aaron can kind of come by if you're having trouble. But yeah, that's the constraining tool. It's pretty simple, but it's a very powerful tool that you should all utilize. It's really cool. So yeah, go for it, and then we'll just float around. So this is the fixed. Oh, okay. Yeah. Also, this. Yeah. Just makes it. Yeah. That just hit. So I do that. Okay. Yeah. That's fine. Yeah. So this one is telling you to set the diameter. So it wants it to all your surroundings. I would just like this. I don't know why with that. If you want horizontal online, yes, so when it says straight, it's like that should have been like document. I would just use on but yeah, in general, just like with the line. No, I like this. I feel like technically instructions are so vague, you could make them concentric to how like
Are you guys done with this little activity? Okay. Do you guys need a quick explanation of how to do each of these? Oh, this one? Okay. So someone had a question for the bottom right question, which is these three circles right there. It asks us to line up the centers of the circles so they're on a horizontal plane, right? So we want the centers of the circle to be on one straight line. So that means you got to use the collinear constraint, right? So the collinear constraint basically makes 3 points in space on the same line, right? So now when I go to collinear right here, it's going to have me choose 3 points in space. So that's 2, and that's 3. So you can see these 3 dots are making a line, hence the collinear thing, right? So to make that line horizontal, right, we have to use some sort of horizontal constraint. But what do we constrain, right? There's an invisible line there that we can't see with our imagination, but it's not physically there in the drawing. So what we have to do here is we use the line tool. We connect each dot to one another, right? So that creates another line right there. And for lines like these that aren't really part of our sketch but help us construct our sketch, these are called construction lines. So to create a construction line, you can just click on any line in your sketch, right? So I want to click this line right here. Sorry, Fusion's being annoying. Yeah, okay. So I press that line in my sketch right there. I right click it, and there is a option to turn it into a normal / construction line. So we just turn it into a construction line, so you can see it's now a dashed line. So that shows that it is not part of your sketch physically, it's more of a construction line. Or you can use the shortcut, just click it and then type X, and it instantly becomes a construction line. So now that our line is there, we want to make it horizontal, right? So what you can do here is utilize the horizontal tool, right? Pull it down a little bit, use our horizontal constraint, and okay, this is annoying. One. Okay, so use our horizontal tool to make the line horizontal. Okay, so that's how you're supposed to do it. One more thing I saw some people doing. So for this question right here, what you're supposed to do is, what it's asking you to do is to first dimension circle 3 to 2. So now it's dimensioned to 2. This little symbol means the diameter is 2. So we did that, and it says to fix circles 1 and 2. So for that, we need to use our fix constraint. It's this little lock right there. What it does is that it it fixes whatever element you're constraining in space. So it's not able to rotate and it's not able to translate, basically. So we click our fix constraint. We pick circles 1 and 2. I don't know why it's not turning green. Oh, there you go. Okay, so you fix those, and fixed objects will become green. So if you fix a line in your sketch, it will become green. That means it is not able to translate or rotate in any way. Okay. Okay, now that we've done that, we just got to make circle number 3 tangent to 1 and 2. And for that, we use the tangent tool. We just click our circle, click another circle, and now they're touching. Lovely. Okay, any questions on that? Awesome. Okay, because I saw some people a little confused by the fixed circles part. That's just using the fix constraint. Any questions? Okay, sweet.
Okay, how's everyone doing? Everyone's good? Raise your hand if you're not finished with this assignment. Okay, cool. Um, I'm guessing she's not done, but I'm just gonna continue. Um, so yeah, that's how you do constraints. It's pretty nice, and it's very powerful. Please utilize them. Like when I was first CADing, like I didn't have any training, right? So I didn't know anything about the geometric constraints. So I'd be like setting things to like 0 inches from each other, and like it really like made it annoying because there were a lot of unnecessary stuff, and it would like break my constraints and it say it's over constraint. So don't like set things to 0. Please do like coincident, or if like something's perpendicular, don't do it at 90 degrees. Just do it perpendicular. It'll make like your sketch look a lot cleaner. It's like, reading like a really nice like paper, right? If there's like typos everywhere, it makes it hard to read, but all the constraints will make it nice and easy and clear to anyone opening it. And it also makes it very easy to edit later on. So let's say like you have a certain like shape, but you want it to be scaled in a certain way. If you use a bunch of geometric constraints and like 1 or 2 dimensional constraints, you can like change 1 or 2 numbers, and then like your part is like magically a different size, and it's really cool. So yeah, that's also why they're powerful. But yeah, now that we know that, we're gonna go into some more fun stuff. So we're gonna make a gear, and we're gonna be using like the mirror and pattern tools along with some of the geometric constraint stuff. So we can go back into Fusion, make a new project, or a new design. So up here, there's that plus thing, or you can Command or Control N, whatever you got to do to make a fresh canvas over here. So we're back in our workspace, and we want to make a gear. So if we look at this sketch over here, this is what we're going to end with. So for me, when I look at this, I'm like, okay, the main thing that I'm going to start with is this circle, and all these features are going to be attached to it, right? So I want to start by making a circle. So I'm going to make a sketch on the top left. I'm going to select this plane. I'm just selecting the top plane. and then I'm going to make a circle from the origin, right? So here's the origin, making a circle. It's blue, but I want it constrained. So over here it says 5. I'm just going to do 5. Again, in this class, you can use whatever dimension you want for like most of the assignments. And if not, then I will tell you to not do it. Okay, so I'm going to set this to 5. It's going to like shrink super small. That's fine. And you see, nice black line. So now we can build off of it. Aaron talked a little bit about construction lines, and this is a really good example of when to use one. So over here, I'm going to make a line. And remember, so construction lines or construction geometry in general is purely for the reference of the person designing the piece or the person editing it, right? So the computer isn't going to use any of your construction geometry when it goes to extrude or revolve it, but it's very useful for adding geometric constraints and adding just more reference geometry that you may not necessarily need in your final extrusion, if that makes sense, or revolve. So here, in this case, I'm just going to make a construction line, but it can be an arc or whatever other shape you want. So over here, I'm going to select line, and then on the right here, there's the option for construction, right? So if you click that, you're going to start making construction lines, and they're going to be dashed lines. So you see, before all these lines were solid, and you see this one is a dashed line. So I'm just going to make this go straight up. Let's see, how long was it? 1.5. So you see it's nice and dashed instead of being solid, which means that it won't be referenced later. I think that's 4. Yeah. So I'm just going to set this to 4 millimeters. And then now we can build off this construction geometry. So it's on the right side. You see this little blue box here. If you click on it when you make a line, then it'll make it construction. You can also just make lines. I'm going to turn it off. You can just make a line as well. And if you want to convert it to a construction line, you can right click it and then tell it to be construction with this normal or construction selection. So yeah, you can change it back and forth if you want. So what I'm going to do here is I'm going to make 2 more lines. So I'm going to build this line off of the end of the construction line, and I'm going to go down at an angle. And now you see I turned off construction geometry. If you didn't, you can right click and undo it. But you want these to be like solid normal lines. So I'm going to add some dimensions here. I believe that was it. And then, oops. Again, you don't need to follow these exactly. So now you see over here, I have like kind of a like 1/2 of a tooth for the gear, if that makes sense. Is everyone up to this point yet? Anyone not at this point? Okay, cool. So now that we're here, we can use the mirror tool to basically copy the gear profile onto the other side, right? So over here next to the sketch dimension tool, there's this like double-sided triangle thing, which is the mirror tool. And over here, there's object selection and mirror line. So you first select the things that you want to be copied. So I want these 2 lines to be mirrored. And then over here, you can select the mirror line by clicking mirror line. And then I'm going to click the construction line. So now you see it gives me a preview, and it's like duplicated onto the other side. I'm going to press OK. And now I have a full tooth. And the really useful part about this is that whenever I edit any of these dimensions, it will change on all the mirrored parts as well. So let's say I wanted this to be 100 degrees instead of 110. They both like are copied because it's mirrored, and all of the features that you change will change for that part as well. Does that make sense? Okay, cool. Is everyone up to this point? No? Okay. If you want to constrain it.
I like more like all of them. I've got I grade like that. I just have it to where like the points are coming together.
How do you set the angle between? Is that like a control?
The angle, you have to click like the diagonal line and the straight line. There's a different way you can do it. What I'm doing is I'm describing a regular polygon into like diagonal.
So like,
Like push that diagonal line to the top and
oh, like bit, like this.
yeah.
All right, is everyone good?
Gaps between them. Yeah. How gears work literally. Yeah.
I like to use if you want a better representation of what it actually looks like, just click on the model class and you can actually see the vertical type. That's
Yeah, that's what I mean.
You have to go well, it's like the whole version. Then you gotta go on that drops out right under mold. And you click the inside thing. I'm just trying to make it symmetrical. So lost spokes. No, 8 spokes, but I was gonna say. As far as I'm aware. I'll know what you're doing. So your way I started the third grade. Yeah. So if you're not
lot of you are doing really well and you've already patterned the gear, but for those of you who haven't done it yet, I'm just going to run it through with you real quick. So now that we have the gear profile, what we're going to do is we're going to duplicate it multiple times around the circle to make a full gear, right? So what we can do is we can first go under create and circular pattern right under the mirror tool, and then it'll ask you to select objects and a center point. So the objects that we want in a circle is the gear profile or the tooth profile. So I'm going to select these 4 lines over here, and then the center point will be the center of the circle. And then now you see it gives us like a preview. So right now the quantity is 3 and it looks like a really weird fidget spinner. So if you want it to look more like a gear, you can increase the number and you'll have more teeth. So like 14. And now we have nice preview. I'm going to press OK. And now it has duplicated it around the circle. And again, it's really nice because if you change any of the dimensions on the original profile, it'll change it for everything, right? So if I wanted this to be 3.5, it changes all of them, which is really, really helpful. Oops, that's too much. So a lot of these things are just here, so you can edit your parts very easily later. If you're making individual simple parts, it may not seem like a big deal, but later when you make more complicated things, it becomes a big deal. So now that I like this profile, I'm going to press finish sketch, and then I'm going to extrude it just like any other part. In this case, we have to select all the tooth profiles. And I'm just going to say I want this to be like 5 millimeters, maybe 10. So now, oh shit, that's a really fat ear. Okay, I'm gonna fix that real quick. So if you want to fix it, you right click, edit feature, maybe make it like 3. Okay, yeah, that looks better. Cool. So now we have this. What's up? Oh, okay. So now we have this gear. Over here, you see there's a threaded hole. So what we want to do is we're going to use the hole feature in Fusion. And the reason why this is important is when you go to manufacture your part, especially with like CNC machines, if you just you could just take like a sketch and negatively extrude like a circle, but you lose the data in the sense that it just thinks that there's a hole there and not like an actual hole, if that makes sense. It's just like a negative extrusion and not a hole. So the reason you use this is if you want to program the machine and you use the hole tool, then it'll know that it wants you want to drill a hole there instead of just like cutting it out with like an end mill. So what I'm going to do is I'm just going to make a sketch and select a point. So I'm going to do a sketch and I want it to be at the origin. So under create, there's this point thing and it just allows you to create like a dot, right? So I'm just going to click on the origin, but this is nice for if you have a bunch of holes, you can create a bunch of different points and dimension them in the position you want, and then you can use the hole tool. So once I have this, I'm going to press finish sketch, and then now I'm going to use this magical hole tool. So you click on it, and it's going to ask you like where you want to drill the hole. I'm going to click on this point that I created, and now it'll give you a bunch of options, right? So like if it's just like a straight cut or like a counter bore or countersink, all that fun stuff, it gives you a lot of options. So in this case, you can even choose like tapped holes and stuff like that. So if you look over here, there's like little threads cut into this hole. So I want that. I'm just going to click on it. And then it'll allow you to even like specify thread types, right? And all of this is like very valuable data when you go to machine stuff, which is why I really recommend you use the whole tool for things like this. Also, it makes it really convenient to make threads because I don't think you want to CAD threads because it's not fun. So yeah, over here you can select the kind. I think this is fine, so I'm just gonna press OK, and then boom, I have these threads on my part. Oh, I didn't make it go all the way through. I'll fix that in a bit. But again, this is why we tell you that your timeline is important. So week 2, just so everyone knows, when you're submitting your homework, please submit it with your timelines. So the timeline is this little bar on the bottom, and it basically runs me through how you made your part. And if you don't do it, if you don't submit it, I won't know how you did it, right? And there's some like techniques that we want you to utilize just to teach you good habits. So please show me your timeline, and that will show me that you use the whole tool and stuff like that. So over here, I'm just going to edit this and make the whole longer through all. And now it goes through the whole thing. Yay. So that was the whole gear assignment. Is everyone caught up to this? Yeah, what's up? Okay, so I'm purely talking about this in the sense of like holes. But if it's like a weird like star-shaped thing, then yeah, negative extrusion is like totally fine. This isn't super important for like 3D printing, but it definitely is important for like CNC machines at like Bechtel. And I'm just like giving you this as a tool so you know how to use it for those machines later if you do that. Does anyone have questions? Yes, no? Okay, I need to plug in my laptop because it's going to die. But we will start the next assignment in 1 moment. Oh, it's not. Okay. Okay. So now that you guys know how to make the gear, we're going to move on to something a bit more advanced. So this is our hair dryer assignment. And basically, we're going to make this really jank hair dryer. So, so basically, when you're making parts, there's often times where you want to use or you want to start and reference a plane that may not exist. So this assignment is teaching you how to make planes so you can add planes wherever you want. And it's pretty nice to make different things. In this case, we're using it for a loft. So here, I'm just going to press the show button, but you can see these like orange squares here. Those are your planes, right? And when you make a part, you start with 3 planes, like the X plane, the Y plane, and the Z plane, right? But there are times where you want to reference somewhere else. So in this case, because we're making this hair dryer, we want to make a couple of different lofts, or we're going to make a loft, and that requires us to use more planes. So if you want to make a new plane, you go under construct up here in the top right, and there's a bunch of options, right? In this case, we're going to use the offset plane, and I believe like the mid plane and the tangent plane are also very useful. But right now, I'm just going to choose the offset plane. And again, the nice thing about Fusion is that if you hover over a tool, it'll usually tell you what it does. So if you forget for whatever reason, you can just hover over it and it'll tell you, hey, like you're making a plane offset from another plane, right? So I'm going to click that. It'll give me a couple options. I want to offset it from this plane, the XZ plane, right? So I'm just going to click on it, and then it'll ask me for a distance. So let's just do like 30, right? And now I have this plane. You can see it's like floating above like this gridded line because it's floating above the origin, and that's what we want, right? So for the hair dryer, we want to make a couple other planes. So I'm just going to use a couple of the tools like the mid plane, and this one creates a new plane in between two existing planes. So here I want, let's say I'm going to select these two planes, and you can see another plane like appears in between the first two, right? Now they're like perfectly spaced, which is cool. And then I'm just going to make one more offset from the top plane, maybe like 20, or like 10, 15, I don't know. Cool. Now we have like a stack of planes. Oh, they're all like the same. I want to just change this, make it look weird. Okay, so cool. So now we have different planes. We can start to create our loft. So how the loft works is you draw multiple sketches on different planes, and then the loft tool will just like use math and stuff to like combine and make a really nice like smooth curve, and it'll create like a solid body. So you see on the left of the presentation there's like 4 circles, and then on the right is like this hair dryer looking shape. Basically the loft tool will just create a nice flowy curve and create a solid body. You can also use it to like make a vase or something if you want. So I'm going to go create sketches. I'm going to select the bottom plane. I'm just going to create a circle, add a quick dimension here. I'm going to make this like 20. And then this sketch is done, right? I'm going to make another sketch, and instead of selecting this bottom plane, I'm going to move a little bit up. I'm going to make sure I choose the plane above it. I'm going to draw another sketch. And again, I'm drawing all these circles at the origin. If you don't, then you're going to get like a weird lopsided loft, and it's going to look funny, but it doesn't really look like a hairdryer. So I'm going to change this to like 40 and make another one on this plane. I'm going to make this one like slightly smaller, maybe like 30. And then for the last one, I'm going to make it, let's say, like 35. Cool. So now you see we have this loft, or it's prepared for a loft. We have these 4 circles. Now we want to create this loft. So I believe under here, yeah. So if you go under create and you click loft, again, if you hover it, it'll tell you what it's going to do. You're going to click loft. Under profiles, you want to select all the circles. It's under the create tool on the top up here. Make sure you select, I believe the selection order matters, so make sure you select the profiles in a line. But then when you select them and press OK, you should get this cool vase looking part. Does that make sense to everyone? Nice. Okay, you guys are all doing like super well. This is great. So now that we have this like solid hair dryer, we want to make it hollow on the inside, right? And a good way to do that is to use a shell. So I believe over here, it's not here, or modify. I forget. Am I like blind? Okay, yeah, there it is. So here, the shell tool will like hollow out the inside. So I'm just going to click on it, and I'm just going to click on this face. I'm going to specify a thickness, maybe like 2. I'm just going to click OK. Now you see it's nice and hollow on the inside. Fun stuff. Okay, add a fillet. So, like on the hammer, we're going to use a fillet to make the edge nice and round. I'm going to use that, maybe like 1 millimeter. So, yay, now you won't get cut by your hairdryer. Is everyone up to date? I know a lot of you are doing pretty well.
Quick question: why does that be seen inside as if like it's a real object that's been? Why is it like that?
Oh, the seam. I think it's mostly just there, like when it renders it, it just will create a seam at a random angle. I'm not honestly sure why,
So why would it be
but
axis,
like
but
it's
yeah,
like
I think that's where it rotates around. That's the edge.
yeah, I'm just gonna assume it's just the way it generates it, like on the computer. But like it is like smooth, right? There's no like, there shouldn't be a line if you went to 3D print it, if that makes sense. Yeah. Yeah, you'll see that in a lot of programs. They just kind of have like random seams in places. Like you'll see it on fillets sometimes as well. I'm Meki. Yeah.
How do you change the dimension of something after you like set?
Yeah, so I mean that's what the timeline is for, right? So let's say you see this on the bottom, you can like go back in time and like edit, oh what the heck. You can edit sketches. So like you see, like let's say I didn't really like the flared end on the top. I can like right click and edit the sketch and it'll go back and let me change it. So
Oh, and then you just like click on the dimension and it lets you.
yep. So that's why CAD is so powerful, because you can go back and change things. So like I changed it to 35 and then now like it did all the math and nothing like broke, if that makes sense. Doing good. Did you finish it already?
Almost. I can't put an offset sketch in the bottom of it.
Okay, yeah, we're getting there. I'm pretty sure it's a tangent plane or something. Yeah. Or shit, I forget. I'm pretty sure it's offset plane. Okay, so now that we have like the hairdryer body, we can add the handle to it, right? So in this case, I'm gonna make an offset plane just going in this direction, and I'm just gonna set it to like, I don't know, 5, maybe more, like 10. So this plane is just kind of intersecting with the hairdryer. I'm gonna show you a trick later on how we can fix this. But I'm just gonna enter the sketch on that new plane we made, and then I'm gonna make a new circle on this line right here. I'm gonna add some dimensions to fully constrain it, so like 12 and 14 seems good. And then again, you can use these geometric constraints to fully constrain it. So in this case, the circle is constrained height-wise, but not like vertically, right? So I can use the horizontal/vertical constraint. I'm going to click the circle, click the origin, and then it like snaps into place. It's fully constrained and we're happy. So that's about centered and where I want it to be. I'm going to press finish sketch, and then I'm going to extrude it, let's say like 50. So here, Fusion thinks I want to cut a hole out of the handle, or out of the body, but I'm going to change the operation to join. I'm going to press OK, and you see we have this handle here, right? But if you notice, there's also like this random handle inside of the body, right? And the cool thing about Fusion and a lot of CAD programs is you can change the order in which you do operations, right? So in this case, like this area was shelled out, but if I want, I can move it by editing the timeline. I can shift it over here, and then that is now gone. It makes the whole thing hollow, right? So that's a good example of just showing you like how powerful Fusion and CAD programs are. You can move your timeline around, and if you do it well, then it shouldn't break for most things. But yeah, the body is now nice and hollow. I'm happy with that. Yeah. Does that make sense?
I'd like to see
Oh, and then like choose the place, like shadows and
Maybe I think it's probably
could you explain what to do about like it set my circle like at the center point, like did you set the circle at like at the side?
I just made a plan that was step.
Oh, okay.
Like you can honestly that's fine because if you change where the shallow
Oh, like if I did the shallow down.
or like what I just showed is that after see like this sticky
Yeah, sorry. I don't know.
no, you're good.
Like
You're good.
joint.
So like you can move like the features, right? So before like the extrusion was like this, right? But if you go into the timeline, you can select the shell and I can drag it in the timeline, right? So I like selected the shell to do the shell like it's yeah. So like how it works is like it will run through each of those operations in order, and if you change the order, you can get different outcomes. Yeah. Pretty cool. Also, for those who didn't know, if you want to like watch it like a movie, you can like click on the play button and it will like do each operation in order, and it's like kind of cool. Especially when you make like big assemblies and stuff like that, it's really cool. You can like see the parts like coming in and stuff. Does that make sense to everyone? I think
with that kind of person, you might have like a big complex machine. Like you could imagine it down to like the exact dimensions of the screws. This you could do. You have like an engine. Wow, this is terrible. No. When I go, you can all put together. Anyway, My oldest crashed. And now I need to restart and stuff.
Oh, yeah. Yeah, I don't know why it does that. It just like disappears sometimes. Um, for those of you who haven't done the chamfer yet, you can just go under modify and chamfer, and you just like select the edge of the handle, and then it'll make a nice chamfer. But now we're gonna go into the wire, and to make the wire, we're gonna be creating a sweep. So similar to the loft, a sweep requires more than one sketch, and it's basically like a path and like a profile, if that makes sense. So you're gonna create like a path for the profile to follow. So in this case, the path is like this squiggly line, and the profile is gonna be a circle, and that'll basically be your wire for this assignment. So first, I'm just going to start by making a circle because it's nice and simple. I want the circle to come out of the center of the handle. So I'm going to make a sketch, select the circle, and then I'm going to draw a quick circle on the center. It's nice and constrained. I'm going to press finish. I'm not going to extrude it yet because we're going to make the wire coming off of it. To do that, we're going to be drawing a line off of the handle. So I'm going to create another sketch. I'm going to select this plane here, and this plane is cutting straight down the center of this hair dryer, right? That's what we want. So again, this is why like positioning your part strategically is important. So if you didn't put it on the origin, then you might have to create another plane. So yeah, I want it to be coming off the center over here. I'm just going to make a straight line coming off there. And then I'm going to make a spline. So I'm just going to make this weird, crazy wire shape. This fun little line. Over here, I want this line to be tangent so it's nice and smooth. So I'm going to click the tangent tool, click the line, click the spline. Now it's nice and tangent. Now I'm nice and happy. This wire is kind of long, but that's fine. But now we have our spline. Constrain the spline. Well, I'm just leaving it loose just because it's like kind of an organic shape. So it's okay if it's not black in this case, but generally you want it to be constrained. Is everyone up to this point?
So once you get the plane tied down the center of the jar, what do you do then?
You draw a line starting from the center of that circle that you drew before, and then you.
That's your wire.
Yeah, that's the beginning of your wire. Yeah.
So since the plane that the like circle is on that we set in the middle of the end is
Yeah.
like going this way, how do you get it where you can draw a line that's going like in a perpendicular?
Yeah. So because we're making a spline, it's going to be two separate sketches, right? So once you finish sketching the circle, yeah, you're going to create another sketch on another plane that goes straight through the center of the circle. Yeah.
Gorgeous. Nothing circular. Narrow something is cool. Yeah, there's like $1,000. Maybe like actually, you don't even need to write. Oh, if you do it without the right click, it lets you select stuff. You can just do it with your. Yeah, that's good. Like the regular select. I don't know. Back to where you started. Yeah, I think what it is that they programmed it to work with the left, and they didn't bother to turn it off. I mean, like, yeah, no, because look, the way it works, the way it must be programmed is it must say, okay, mouse has in it, so then it says it's gonna follow, right? Oh, you're left. I'm left. That's weird.
I'm gonna talk about the homework in like a second, but basically, the homework so I have to fix that or it is what you're doing, but it's missing a couple numbers. So those missing numbers will make it so like you don't have it. So that's like the point of this assignment is so yeah, once you have this line and circle, you can finish the sketch and then you can create a sweep. Oh, I've been calling it spline. Okay. I can't talk today. So yeah, you want to create a sweep and then it'll give you a couple drop down menus. There's the profile and the path. So the profile should be the circle, so you can select the circle, and then you can choose the path as that the line and the spline we made. I think it okay. It doesn't like my line. I need to fix that. I'm just gonna delete this for now because it's all right. See you, man. Okay. Yeah. So if your spline was done right, it should make a nice wire, but my spline was broken, so it's just like a nub. I will fix that right now, but yeah, that's the sweep tool. Awesome. Yeah. I need to fix that. That's my bad. Yay. Wire. Okay, well that is that assignment. Yeah. Your homework assignment is to basically recreate this aluminum extrusion profile. Um, there's some missing dimensions on this photo, so I'm gonna send the updated one later tonight or tomorrow. So if you use this, you're gonna be like, why are there blue lines? and then you're gonna remember that some of them are missing. So just feel free to wait for those to be uploaded. I'll send a message out on the Discord. But yeah, if you are all caught up for today, then you are free to go. Thank you so much for coming. I will see you next week.
Hopefully on time.
Yes, hopefully. Yeah, if you didn't do the attendance, please fill that out so I know that you're here. But yeah, other than that, thank you for coming, and see you next time.
Yeah.
Yay.